12 with 11. I'm going to add that and hit apply. All right. So now we've eliminated a lot of the January runs. Okay. That we have February, March, April. We kept most of those because remember we already knew that they were pretty similar. Okay. We eliminated some of the transition in May because we saw some of the transition. You know, we eliminated most of June. You know, there's some good runs in June. July, which was really probably their best month, you know, January and July, we kept most of those. Okay, August, we could see the transition in August and September. Okay, you know, and then we have October, which is a very distinct difference. So, like, let's say I want to look at July versus October. Okay, so October's bad, so that's red. You know, that's why I clicked on July 1st because I knew it'd be blue. And then I can do a group-to-group comparison between those. I'm going to sort those as ascending. And I'm just going to eliminate a bunch of this stuff. Not eliminate, but I'm going to hide it. I'm going to hide. I mean, I could exclude that because those are not driving things, right? And then rerun the model again, right? But that's okay. So we have a couple of the other color ones that was one of the quality tests, which I probably I've eliminated in other ones. So let's just go ahead and do that. Let's see if that's one of them too. Yep. Okay, let's go ahead and exclude those because all they are is confirming they're part of the same test, quality test. It's a color test. And so all they're doing is confirming what we already know. Take it out of the model. You don't need it. Because all it's doing is contributing to that separation. Okay. So now I bet when we auto fit that, it's going to look quite different. I bet it's going to get muddy again. And you see the scores. Well, the scores are still pretty high. Okay. We got a little bit more muddiness. Okay. That's okay. All right. So let's go back to month number. Color category 12 by 11, add and apply. All right, so let's look at July versus October. Do a group-to-group comparison. Sort ascending. Let's see. Go there to there. Okay. And I'm just going to hide it this time. I'm not going to exclude it. All right. So we have this particular differential pressure. Okay. There's blue versus red. Drastic difference. Okay. July to October only. Not good, bad. Just July to October. But what's interesting is they made a step change back here in August 20th on a particular batch number. Okay, batch number 1496, they made a change. Drastic change. Okay, we didn't have problems till like September 23rd. Right? But you can see they're running very differently than they were back then. Okay, so that's one thing. This is why multivariate is important because that's not the only contributor. Well, maybe this one also had something to do with it, and I don't know what this one is. This was another differential pressure. Okay, in one of their feeds. Okay, so again, it went up as well. Okay, let's see, what was this one? That was another color one. The cycle number that has nothing to do with it. Okay, there's an outlet temperature. Okay, lost the sensor. You can see a flat line because, hey, we were about the same. Sensor problem. Okay, could probably eliminate that one, right? Because that sensor's been pretty stable all year long, right? So that's probably not a problem. Okay, but you can see why it contributed, right? So this is one of these correlation, not causation kind of things, right? Let's see. Here's a gas rate. Okay, and we can see this was around October 20th. Okay, it was starting to go up, and then it got really crazy. It got kind of unstable. Okay, but it was starting to trend up. Okay, over from July up into October. Which they were actually very curious about this one.
It is interesting.
Okay, because it got noisier. It was starting to trend up, then it got really noisy, starting about October 20th, right? So, this is kind of the way we attack these kind of problems. And, we could have done good versus bad, but I thought the July to October, which was, we saw was a good versus bad month. And just in case of, video editing, I'll go ahead and pull that file up in Power BI, just to kind of confirm and show people like, hey, we looked at this, and what we found was that, their performance in July was really good. Their performance in October was really poor, right? And sorry, my wife is leaving out the garage, so if you hear growling through the thing, my office is over our garage. Sorry. All right, so April, pretty bad month, right? July, really good month. October, pretty bad month, right? So it would be interesting, to see that. Now, how about we take model 12 and let's look at April versus, let's do it the other way. Let's do July versus April, so that way April's bad, okay? And let's do a group to group comparison, right? I'll sort that ascending. Okay. And we'll see because it's going to be a different answer. All right, so that's one of the color ones. They have an unload step time that changed, okay, that dropped down. Okay, that's one thing. I'm not sure what this is. I can't remember what that was. I think that was another lab test, but it did come down.
Interesting.
Okay. Let's see. Let's see what this one is on the other side. That was another lab test, right? So that had come up from, July was much better than June. That was probably more just confirming something they already knew. That's probably not telling them anything. The cycle number has nothing to do with it. I should take that out. This may be like a water phase step time or something like that. Okay, it's up a little bit higher. It's kind of running just under 150 minutes, and now it's probably over 250 when they're doing well. But again, you can see that it was a different set of things that was driving it mathematically different, right? But the thing is some of the stuff we already see, that has nothing to do with it because that's just another one of the same color tests. It's just a different part of it. Or it's the cycle number. I should have eliminated that, right? So that's why sometimes I think a data scientist really kind of struggles because they don't really know. Like I know that, like when I see cycle number or I see those things, like, I know, that's the same thing, or it has nothing to do with it, right? And so I think it's going to be very important as time goes on for these kinds of tools to be able to be used by somebody like me. I don't have to know all the math behind it. I don't have to know how the algorithm works. I just have to know, does that algorithm detect the kind of problem I'm looking for?